Thank you, Luis, for the invitation. Thank you, Silvana, as well. I don't know if she's here now. Silvana, thank you as well for all the committee that organized the Silver Laser. And it's a huge pleasure to be here speaking to such a powerful community that can be, especially in face of the disagreements that we've been facing recently here in Brazil. I've been here in Brazil for the past 5-6 months, and in the Amazon. And the other day, when I was in a very remote village in the Amazon, I stopped by to have like some food in a restaurant, a very local restaurant there. And there was a big screen, and I saw Douglas Morton on TV saying about how deforestation is really happening, is really increasing. And that was really powerful to change, to sparkle some discussions in Brazil, because as a Brazilian, sometimes it's really difficult to have a voice here. So thank you, and please do speak out when you can, when you have data, when you have like clear evidences that something's happened. So I'm from the University of Helsinki. I'm a postdoctoral researcher there. But I'm going to speak a little bit about my previous research as a PhD student at the University of Cambridge, and now what I've been doing in Helsinki. So, well, my previous work at the University of Cambridge was to use airborne LiDAR data to understand the effects of fragmentation and El Niño droughts on tropical forests. We've been involved with a bunch of people who gave us data, especially David Coombs, who was my supervisor and guided me through this this project. Greg Asner, who also provided some data and some useful guide as well. And Ruben Balbuena, who is also here in the audience. And so I'm going to take you now to, sorry. Can you, yeah, no. So I'm going to take you now, this is the map of Asia. I'm going to take you to the Southeast Asia on the island of Borneo, where I spent about 1 year doing lots of field measurements, for example, like field spectroscopy and identifying tree species. And this is among the tallest forests and the tallest tropical trees in the world. So it's very carbon dense, and it's one of the most diverse forests in the world as well. But this whole island, it's been losing a lot of forest because of the oil palm expansion and logging and rubber plantations and infrastructure. And to understand, to investigate a bit how this logging and how this oil palm expansion is affecting forest ecosystems, we've got a project that is called SAFE Project, which stands for Stability of Altered Forest Ecosystems in Malaysia. It's a huge project with a very fantastic plot network there that people have been monitoring for a long time. So we can see here that in 4 decades only, we lost about 50% of the forest cover on Borneo, mostly because of this oil palm expansion, because this area, they produce 80% of the whole palm oil that is consumed in the world. And this is like some pictures I took when I was in Sabah, one of the states there, and you can see primary old growth forests there, but you can see this picture here in the middle. It's a very common type of thing that you'd see there, like lots of huge areas with oil palm plantations, but a lot of areas with logged forests, and this is like lots of like loading areas and skid trails and really degraded, disturbed forests. And it was with this background here that we had an airborne LiDAR survey over 25,000 hectares in Sabah, in the northern part of Borneo. It was a Natural Environment Research Council, NERC, a UK-based agency that funded this project. So in 2014, we had an airborne LiDAR there, and we used, it was a 1 meter resolution. We used a 1 meter resolution pixel to produce some top of canopy height maps using this LiDAR survey. And this was like a 26,000 hectare surveyed with average post density was 7.3. We used the discrete height to develop some works on carbon mapping. And this LiDAR survey, it included the SAFE project, which is the world's largest forest fragmentation experiment in the world. There's like almost 200 plots networked there, and people have been monitoring tree measurements, trees, and like doing some DBH and height and species identification, but also microclimate, for example, temperature and relative humidity, but also leaf area index from 2011 until very recently. And our group, Combs Lab in the University of Cambridge, came out with lots of some papers, for example, to understand how topography shaped forest and structure, the functions of these tropical forests, and how topography affected microclimate, everything using this first LiDAR data set. And also developing the use of LiDAR to investigate area-based, to develop the use of area-based and tree-centric approaches on tropical forests and oil palm plantations. But also we had some very interesting papers coming out of these. For example, understanding like riparian areas to protect bird communities, but also to investigate the density of Bornean orangutans, and even the occurrence of blood-feeding terrestrial leeches, which in Sabah, it's insane how you go to the field there and you are just covered in leeches all the time. But very interesting, Greg Osner and his team with the Carnegie Airborne Observatory, they overflew the same area that we had our first LiDAR survey, surveyed the whole state of Sabah on Borneo, covering about 2.1 million hectares, which is about 30% of the whole state of Sabah. And Sabah is a huge state. It's like almost the same size as the UK. It's very, very big there. Because the whole island of Borneo is I think it's like the third largest change estimates. And we also try to only use areas that the post density were like more similar to each other, because if we use different, for example, like in the first survey, LiDAR survey, we used like like some areas with post density of about 4 per square meter, and on the second survey we used like 15. That would cause like some differences based on the above ground biomass changes. And very interesting, and for our surprise, when I was there in 2015, we had this El Nino happening in Southeast Asia. And it was considered one of the strongest El Ninos in the past 4 decades. We can see here, this is a paper that came out in Nature Communications by Tirul Malai, that extreme temperatures in Southeast Asia caused by El Nino were worsened by global warming. So we can see here in blue on this graph, on the y-axis, we've got the hot April surface air temperature anomalies. And on the x-axis, we have the year of hot April. So we can see that in 2016 and 1998 and 1983, we had the 3 strongest El Ninos affecting Southeast Asia. But this one in 2016 was particularly hot, the temperatures, because they were worsened by global warming. So also had a global climate change effect on these hot April temperatures. And Of course, El Nino temperatures and precipitation can have a large spatial variability. So we had some mean precipitation estimates from the tropical rainfall measuring mission. So we can see there that like in 2015, we had 2 consecutive months with relatively low precipitation, and 2016 with also lower precipitation, but like lower precipitations compared to the previous years. And we also had microclimate measurements across a plot network of 113 plots. And we measure temperature and relative humidity. We can see that in April 2016, we indeed found hotter temperatures in the microclimate. That microclimate was measured 1 meter on the ground. The height, 1 meter height, and also vapor pressure deficit that is obtained by relative humidity. And there are some papers that show, for example, temperature that drives this VPD, vapor pressure deficit, increases increased temperature can increase VPD, and that is related to higher tree mortality in the United States. But also there's this paper that came out recently by Atticus showing that most trees associated with droughts, 50% of the tall trees associated with droughts, they died in California. And it was the factor most explaining tree mortality was tree height, but also microclimate had its responsibility in these patterns. So the possible tree responses to drought here, we have various responses. It depends on the evolutionary history of the place, the species, and how they are going to respond to these changes. We can have responses varying from physiological responses to reduce transpiration, leaf shedding, but here in the Amazon, for example, some ecophysiologists have showed some evidences that old leaves, they tend to shed their leaves first, but also decrease productivity, cavitation, and finally death. But we don't know what's happening. What are the responses on the island of Borneo? And we are trying to understand that from LiDAR. But from a plot network here of 38 permanent plots from 2012 to 2018, every January we measure the same trees on the same plots. We didn't find evidence there was change in above ground biomass change, but there was a lower productivity during these El Nino droughts. And we didn't also find evidence of mortality. So this is very good news that probably on the island of Borneo, these trees, they probably are less vulnerable, for example, than like trees in the Amazon that can be very vulnerable to strong El Nino events. And good news as well that we were able to use the LiDAR-based measurements of TCH, of top of canopy height, agreed with our plot-based estimates of above ground biomass change. So we can see here we had a relatively good relationship, and but it's very interesting here because when you look at this 0.0 here, we can see that it doesn't go through 0, right? So you can see here that a LiDAR-based top of canopy height change of 0, it doesn't mean that the above ground biomass change on the ground is 0 as well. So there's also something happening here, right? And we thought that it could be leaf shedding as well happening. So when you have leaf shedding, you have a reduction in top of canopy height, and not necessarily that reduction in top of canopy height observed by LiDAR is necessarily correlated to the above ground biomass change. So that's exactly what's happening. When you look at the LAI measures on the ground, we can see there was a reduction of about 18% during the second flight compared to the first flight. But most interesting is that even after 8 months after the drought, after the end of the El Nino in April, we still had a prolonged effect of leaf shedding with decreases in LAI. So here we can see that there was a lower productivity as a response to the El Nino, and no mortality of trees, no increase in mortality of trees, and leaf shedding. And so we now use these LiDAR data across our 25,000 hectares landscape to produce a map that will try to investigate what are the main causes of variation within this landscape. And we found that top of canopy, even top of canopy height trees with like really small forests and really tall forests, they all keep increasing in, are all carbon sinks, right? But it's very interesting that like regenerating forests, trees with forests with top of canopy height of about 5 meters here, they tend to grow more. And that's probably because these regenerating forests, heavily logged forests, they have more acquisitive traits that allow them to grow faster and more than the taller forests. But still, even the taller forests, they increased less, they were still carbon sink, and which is a very positive result. But we found that distance from the edge played a very important role during this time. We can see here there was about 500 meters edge effect. So within these 500 meters, we can see that trees, they can be they can be really affected, especially tall forests, where sometimes they can work as carbon source if they are really close to the edge. We also see topography playing a very important role here, a very significant role. We see in blue that forests in valleys, they tend to grow more, whereas the forest on hilltop or ridges, they tend to grow less, which also, even like when it's not like an El Nino event, it's also common because competition for water and nutrients on ridges, on hilltops tend to be higher compared to valleys and low bottom areas. So it's very interesting to see here like how we can try to design a landscape that will maximize carbon storage in situations of El Nino events, climate change events that we had in 2015-16 on Borneo. So this was like the main outcome of this project.